Hi there, I'm Chris Saxon, the SQL Wizard. In the Cup and Balls episode, we saw how we can use views to make rows move between different tables. Today, we're going to take a look behind the curtain and find out where all those multicolored balls came from. Let's get started. In the cups and balls trick, I had a cups table with different colored views on top of it. Each view selected out the rows of the same color as the view. So we can see in the cups table, I've got my red, green and blue balls, but the red cup just selects out the red ball. Now, when I inserted the blue, green and red balls into the red cup, however, we got all the colors of the rainbow back. How did I do it? Let's take a look. After creating the cups table, I then inserted all the different coloured balls into it, like so. I then saved them in the table. With these in place, I created a materialised view over the top of the cups table. This saved all these different coloured balls into the cups MV. We can see that by querying it like so. I then deleted all the balls out of the cups table, gone and committed it. So at this point, we have an empty cups table and a materialized view with all the different colored balls in it. We can then make these rows reappear using query rewrite. As we can see, there's currently no data in our cups table. However, by setting the query rewrite integrity parameter to stale tolerated, we're telling Oracle that we can trust the data in the materialized view even though it's out of date. So if we do that, set that, when we query the cups table now, we find we get all the colored balls back again. We can verify we're using query rewrite by looking at the explain plan, and we can see we've got a materialized view rewrite operation. If we set query rewrite integrity back to enforced, like so, and query the cups table again, we find it returns nothing. And the explain plan has gone back to a full table access of the cups table. Query rewrite? What's that all about, I hear you ask? This is a feature that you can use in conjunction with materialized views. As we just saw, you can use a materialized view to save the results of a query in a table. If you then execute another select statement which is equivalent to the one that you used in your materialized view, Oracle can, instead of executing your query, just look at those pre-saved results. This can give significant performance benefits when you've got complex queries joining multiple tables or aggregating millions of rows. Under normal circumstances, Oracle will only use query rewrite when the results you saved in your materialized view match the results you'll get when you actually execute your query. Now, this isn't the case here. We've saved a bunch of multicolored balls in the materialized view, but just deleted everything out of the table, so they're different. How can we get Oracle to actually use the materialized view in query rewrite? Let's find out. The final piece of the puzzle is to understand how I actually set the query rewrite integrity parameter. We look at the setup script, we can see that when I said there was no triggers, I was lying. There aren't any on the views themselves, however there is a compound trigger on the cups table. And what this is doing is counting how many rows were inserted in each statement. When a single statement inserts 3 or more, then we alter the session to set the query rewrite integrity to stale tolerated. This means that when I added the red, green and blue balls, we set this, enabling us to use the materialized view with all those multicolored balls saved in them. To wrap up, we need to understand how I got the rows to appear in the red cup, but not the green or the blue cups. Now, the where clause for the green and blue cups just returns the rows that are the same color as the view name. However, with the red cup, I'm returning all the rows that aren't green and aren't blue. This means we're able to see all those multicolored rows when we are selecting the information out of the materialized view. At this point, you may be saying to yourself, stale data? Why would I want that? Why can't my materialized view just always have the up-to-date, correct information? Well, there's 3 reasons why you may wish to use this stale tolerated setting. Let's take a look at them. Firstly, to keep materialized views in sync with the underlying base tables, you have to set them to be fast refresh on commit. Now, there's numerous restrictions around the queries you can use in these types of views. If the query you're writing is sufficiently complicated, it may be you hit these issues and can't use this feature and have to go with periodic refreshes. Secondly, because it's on commit, every time you save a change to the base tables in the materialized view, there's some overhead, extra work involved. And this overhead on commit time may be too great for your transactions in terms of increased response time or extra work on the database. In this case, you may have to go for a scheduled refresh instead. Finally, some tables are insert only, things like transaction tables and fact tables. In this case, when you create your materialized view, everything looking backwards will be up to date and correct. You'll just be missing the most recent inserts. And if you're using these materialized views for historic queries, say yesterday's information, last week's, or even last month's, then the materialized view will work just fine. That was our behind the curtain look at the magical cup and balls trick. We saw how we could use a combination of materialized views along with a query rewrite integrity parameter set to stale tolerated to view information as it looked at some point in the past. This is a potentially powerful feature if you've got complicated queries on historic data which just doesn't change. By using these, you can get potentially dramatic performance improvements in these complex queries. I'm Chris Saxon. Thanks for watching. Thanks for watching. I'm Chris Saxon, the SQL Wizard. Subscribe to my YouTube channel to get future updates on more SQL magic. I'll see you next time.